Hi folks, today we're going to talk about vertical and horizontal stretches and compressions. So last time we talked about translations, right, when we shifted things up and down, left and right, and reflections. Today we're going to talk about compressions and stretches. So we'll start with vertical. Those are the easier ones. And here's the idea. When you stretch or compress, when you're dealing with vertical, look, this is the rule that you're doing. You're just taking that entire function and multiplying it by that factor. Okay, so in this example, our function is f of x is equal to 3x plus 2. And it says we're going to do a vertical compression by a factor of 1/4. Okay, so all that means is I'm taking f of x and I'm multiplying it by 1/4. So 1/4 times f of x. So all that means is in my function, so my new function is g of x, because it said that, g of x there. So I'm taking 1/4 and I'm multiplying it by f of x. F of x is equal to this, so that's what goes here. I end up with 1/4. Let me erase that. That's 1/4 there. And then in parentheses, 3x plus 2. So I'm multiplying my entire function by 1/4. So if I distribute 1/4 to both of those, 1/4 times 3x is the same as 3x over 4. Plus 1/4 times 2 is 2 over 4. So I can clean that up and I can write that as 3/4 x plus 1/2. Right? I can reduce 2/4 down to 1/2. Multiply your entire function by whatever that factor is, whether it's a stretch or a compression in the vertical direction. Multiply the entire function by whatever that factor is. In horizontal, we have a slightly different rule. And here's where it's different. You are going to take whatever that scale factor is, and you are going to take the reciprocal of it. That's what 1 over b means. That means you flip it. Okay? And then you're going to replace x with that flipped value of that factor. So let me explain to you what I mean. We have this function, f of x is equal to 2x minus 1. Our scale factor here is 1/3, so b is 1/3. If I flip that over, it becomes 3. That flipped part is what I substitute in for x. Okay, so my new g of x then, instead of 2x, I now have 2 times 3x. I just replaced x. Okay, I replaced this x, so my 2 stayed there. I replaced this x with this reciprocal of b, 3 times x, because I still have to keep that x in there. Okay, minus 1, because that's still part of my equation, and so I end up with 6x minus 1 as my final answer. So whether it's a horizontal stretch or a compression, whatever that is, flip it and then multiply that by x, and that's what goes in your parentheses. So for example, if I had the function f of x was equal to 5x plus 3, and I did a horizontal stretch of 1/2, or sorry, horizontal stretch of 2. Okay, if I did a horizontal stretch of 2, then what goes in the problem is 1/2. So I then have g of x is equal to, that 5 stays, and now I'm replacing that x with 1/2 x plus 3. Well, 5 times 1/2 is 5/2 x, and then that 3 just stays there. Okay, so that's the difference between vertical and horizontal. Let's look at a couple of examples. They're telling us here vertical stretch. Okay, so that means vertical stretch of 2. That means I'm taking my function and I'm multiplying my function by 2. So I have 2 and then my function is 4x minus 1. And when I distribute, I end up with 8x minus 2. That's my g of x. So my final answer here, g of x is equal to 8x minus 2. That's my answer. In problem number 2, g of x is a horizontal stretch. That means I got to flip it. Okay, I have to flip it. This says 3, but what's going to go in my problem is 1/3 because I have to flip it. So now my g of x is 5 times 1/3 x plus 8. Okay, I replace that x with 1/3 x. And that gives me 5/3 x plus 8. This last problem combines a couple of things. I just want to go through it with you. If I have f of x equals to x and I shift it down 2 units, so I have f of x and then it's equal to x and I shift it down 2 units, then I'm just subtracting 2. Then if I'm doing a vertical stretch of a factor of 5, now I have to take that function f of x and multiply it by 5. So I end up with 5 times x minus 2. And so my answer then is 5x minus 10. So those are some examples of how to do a vertical stretch and compression versus horizontal stretch and compression. The problems for the assignment are very similar to this, so make sure that you understand what's going on in the video before you do the assignment. And I will see you next time. Take care, everybody.